Video 49, Basic Biostatistics, Descriptive Area 4 CHES Sub-Competencies 4.4.3. Review the learning objectives for this video. Descriptive statistics summarize and describe the characteristics of a data set. They are the foundation of all statistical analysis, and I want you to feel really comfortable with them because you will see these concepts tested thoroughly on your certification exam. The three measures of central tendency tell you where the center of your data lies. The mean is the arithmetic average. You calculate it by adding all values in the data set and dividing by the total number of values. For example, if 5 participants scored 70, 80, 85, 90, and 95 on a health knowledge test, the mean is 70 plus 80 plus 85 plus 90 plus 95. Equals 420 divided by 5, which equals 84. The mean is the most commonly used measure of central tendency and works well when data are approximately normally distributed. The median is the middle value when all data points are arranged from lowest to highest. Using the same 5 scores arranged in order 70, 80, 85, 90, 95, the median is 85 because it sits in the middle position. If there is an even number of values, the median is the average of the two middle values. The mode is the most frequently occurring value in the data set. If the scores were 70, 80, 80, 90, and 95, the mode is 80 because it appears twice, while all other values appear only once. A data set can have no mode, one mode, or multiple modes. Now here is a critical exam concept, and I really want you to lock this one in. When should you use the median instead of the mean? The answer is when data are skewed or contain extreme outliers. Outliers are values that are far removed from the rest of the data. They pull the mean in their direction but do not affect the median. For example, if annual household incomes in a community are $30,000, $35,000, $40,000, $45,000, and $500,000, the mean is $130,000, which is not representative of most households. The median of $40,000 provides a much better picture of the typical household. The exam frequently tests this concept, so remember this rule. Outliers distort the mean, so use the median instead. You are going to feel confident with this one. Measures of central tendency tell you where the center of the data is, but they do not tell you how spread out the data are. Measures of variability complete the picture by describing the dispersion of values around the center, and understanding these is going to round out your statistical knowledge beautifully. The range is the simplest measure of variability. It is calculated by subtracting the lowest value from the highest value. If test scores range from 50 to 100, the range is 50. The range is easy to calculate but limited because it only considers two values and is heavily influenced by outliers. Standard deviation is the most important and most commonly used measure of variability, and this is one you are going to want to understand deeply. It represents the average distance that each data point falls from the mean. A small standard deviation means that most data points are close to the mean, indicating that the data are tightly clustered. A large standard deviation means that data points are spread widely around the mean, indicating more variability. For example, imagine two health education classes that both have a mean test score of 80. Class A has a standard deviation of 3, meaning most students scored between 77 and 83. Class B has a standard deviation of 15, meaning scores ranged from 65 to 95. Both classes have the same average, but Class B has much more variability in performance. In a normal distribution, approximately 68% of values fall within one standard deviation of the mean. Approximately 95% fall within two standard deviations, and approximately 99.7% fall within three standard deviations. This is called the 68, 95, 99.7 rule, and it is absolutely worth memorizing for the exam. Variance is simply the standard deviation squared. It is used in many statistical formulas and calculations, but is less intuitive to interpret than standard deviation because it is expressed in squared units. You are making excellent progress with these statistical foundations. Understanding the shape of your data distribution is essential for choosing the right descriptive statistic and the right statistical test. This concept ties together everything you have been learning, and I think you are going to appreciate how it all connects. A normal distribution, also called a bell curve or Gaussian distribution, is symmetric. It has a bell shape where most values cluster around the center and fewer values appear at the extremes. In a perfectly normal distribution, the mean, median, and mode are all equal and located at the center of the curve. Many statistical tests assume that data are normally distributed, so checking this assumption is an important step in data analysis. A skewed distribution is asymmetric, with a longer tail extending to one side. There are two types: a positively skewed distribution, also called right skewed, has a longer tail extending to the right toward higher values. In a positively skewed distribution, the mean is greater than the median because the extreme high values pull the mean to the right. Income data are a classic example of positive skew because most people earn moderate incomes while a few earn extremely high incomes. A negatively skewed distribution, also called left skewed, has a longer tail extending to the left toward lower values. In a negatively skewed distribution, the mean is less than the median because the extreme low values pull the mean to the left. Test scores on an easy exam are a classic example of negative skew because most students score high while a few score very low. Here's a memory technique that is going to make this easy for you on the exam. The tail tells the direction of the skew. If the tail points right, it is positively skewed, which means right skewed. If the tail points left, it is negatively skewed, which means left skewed. And remember, in skewed distributions, the mean is always pulled toward the tail. This is why the median is preferred over the mean when data are skewed. The median stays in the center regardless of extreme values, while the mean follows the tail. You have now built a strong understanding of descriptive statistics, from central tendency through variability and distributions. That is a complete toolkit that is going to serve you well. Read the scenario stem aloud. Give students 30 seconds to consider options before advancing. The correct answer is C. The median of 3.5 servings is the most representative measure because the data are positively skewed. The three participants reporting 15 or more servings per day are outliers that pull the mean upward to 6.2 servings, which does not reflect the typical participant who eats 2 to 4 servings. The median is not affected by these extreme values and better represents the central tendency of the majority of participants. Option A is technically true that the mean includes all values, but that is precisely the problem when outliers are present. Option B could provide useful information but was not calculated in the scenario. Option D describes variability, not central tendency. Summarize the key takeaways